everyone. Welcome to the course Data Structures using C. Today we are going to study Introduction. What is data structures? The data structure name indicates itself that organizing the data in memory. There are many ways of organizing the data in the memory. As we have already seen, one of the data structures, that is array in C language. Array is a collection of memory elements in which data is stored sequentially, that is, one after another. In other words, we can say that array stores the element in a continuous manner. This organization of data is done with the help of an array of data structures. There are also other ways to organize the data in memory. Let's see the different types of data structures, or we can also say that data structure is a branch of computer science. The study of data structure allows us to understand the organization of data and the management of the data flow in order to increase the efficiency of any process or program. Data structure is a particular way of storing and organizing data in the memory of the computer so that these data can easily be retrieved and efficiently utilized in the future when required. The data can be managed in various ways, like the logical or mathematical model for a specific organization of data is known as a data structure. What are the scope of data structures? The scope of a particular data model depends on two factors. First, it must be loaded enough into the structure to reflect the definite correlation of the data with a real-world object. Second, the formation should be so straightforward that one can adapt to process the data efficiently whenever necessary. Some examples, let's see. Data structures are arrays, linked list, stack, queue, trees, etc. Data structures are widely used in almost every aspect of computer science, that is, compiler design, operating systems, graphics, artificial intelligence, and many more. The data structure is not any programming language like C, C++, Java, etc. It is a set of algorithms that we can use in any programming language to structure the data in the memory. To structure the data in memory, n numbers of algorithms were proposed, and all these algorithms are known as abstract data types. These abstract data types are the set of rules. How can we tell that the abstract data types work? It is just a data is a collection of facts and figures or a set of values or values of a specific format that refers to a single set of item values. The data items are then classified into sub-items, which is the group of items that are not known as the simple primary form of the item. Basic terminologies related to data structures. Data structures are the building blocks of any software or program. Selecting the suitable data structure for a program is an extremely challenging task for a programmer. The following are some fundamental terminologies used whenever the data structures are involved. Let's see what are the terminologies. Very first is the data. We can define data as an elementary value or a collection of values. For example, the employee's name and ID are the data related to the employee. What is data items? A single unit of value is known as data item. Group items. Data items are known as group items. For example, an employee name can have a first, middle, and last name. So this comes under the group items. Elementary items. Data items that are unable to divide into sub-items are known as elementary items. For example, the ID of an employee, right? So next is the entity and attributes. A class of certain objects is represented by an entity. It consists of different attributes. Each attribute symbolizes the specific property of that entity. Entities with similar attributes form an entity set. Each attribute of an entity set has a range of values, the set of all possible values that could be assigned to the specific attributes. The term information is sometimes utilized for data with given attributes of meaningful or processed data. Field. What is field? A single elementary unit of information symbolizing the attribute of an entity is known as field. Record. What is record? A collection of different data items are known as a record. For example, if we talk about the employee entity, then its name, ID, address and job title can be grouped to form the record for the employee. So, this is an example of entity and attributes. What is file? A collection of different records of one entity type is known as a file. For example, if there are 100 employees, there will be 25 records in the related file containing data about each employee. Understanding the need of data structure, why it is required? As applications are becoming more complex and the amount of data is increasing every day, which may lead to problems with data searching, processing, speed, multiple request handling, and many more. Data structures support different methods to organize, manage, and store data efficiently. With the help of data structures, we can easily traverse the data items. Data structures provide efficiency, reusability, and abstraction. Why should we learn data structures? Data structures and algorithms are two of the key aspects of computer science. Data structures allow us to organize and store data, whereas algorithms allow us to process that data meaningfully. Learning data structures and algorithms will help us become better programmers. We will be able to write code that is more effective and reliable. We will also be able to solve problems more quickly and efficiently. Understanding the objectives of data structures satisfy two complementary objectives. First, correctness. What is correctness? Data structures are designed to operate correctly for all kinds of inputs based on the domain of interest. In other words, correctness forms the primary objective of data structures, which always depends upon the problems that the data structure is meant to solve. Secondly, efficiency. Data structures also require to be efficient. It should process the data quickly without utilizing many computer resources like memory space. In a real-time state, the efficiency of a data structure is a key factor in determining the success and failure of the process. Understanding some key features of data structures. Some of the significant features of data structures are, first and very important, that is robustness. Generally, all computer programmers aim to produce software that yields correct output for every possible input, along with efficient execution on all hardware platforms. This type of robust software must manage both valid and invalid inputs. Second, adaptability. Building software applications like web browser, word processors and internet search engine include huge software systems that require correct and efficient working or execution for many years. Moreover, software evolves due to emerging technologies or ever-changing market conditions. Next is the reusability. The features like reusability and adaptability go hand in hand. It is known that the programmer needs many resources to build any software, making it a costly enterprise. However, if the software is developed in a reusable and adaptable way, that it can be applied in most future applications. Thus, by executing quality data structures, it is possible to build reusable software, which appears to be cost-effective and time-saving. Classification of data structures. Data structure is classified into two formats, that is primitive and non-primitive data structures. Primitives are like data stored in array of a same type, and non-primitive is the data stored in array of different types. So we can say there are various types in primitive data structure. For example, integer, float, character, boolean. Non-primitive data structure is divided into two parts: linear data structure and non-linear data structure. Linear data structure is static and dynamic. Static means array, and then dynamic means linked list, stack and queue. Non-linear data structure is something not arranged in a sequential way. It can be example like tree and graphs. So, a data structure delivers a structured set of variables related to each other in various ways. It forms the basis of a programming tool that signifies the relationship between the data elements and allows programmers to process the data efficiently. We can classify data structures into two categories, as I said, primitive data structure and non-primitive data structure. Primitive data structures are the data structures consisting of the numbers and the characters that come built into programs. These data structures can be manipulated or operated directly by machine-level instructions. Basic data types, as I said earlier also, that it belongs the data types like integer, float, character and boolean come under the primitive data structures. These data types are also called simple data types, as they contain characters that can't be divided further, right? And non-primitive data structures are those data structures derived from primitive data structures. These data structures can't be manipulated or operated directly by machine-level instructions. The focus of these data structures is on forming a set of data elements that is either homogeneous, that is same data types, or heterogeneous, different data types. Based on the structure and arrangement of data, we can divide these data structures into two subcategories: linear data structure and non-linear data structures. Linear data structures that preserves a linear connection among its data element is known as a linear data structure. The arrangement of the data is done linearly, where each element consists of the successors and predecessors except the first and the last data element. However, it is not necessarily true in the case of memory, as the arrangement may not be sequential. Based on memory allocation, the linear data structures are further classified into two types: static data structures, which comes, and dynamic data structures. So, for example, what is static data structures? The data structures having a fixed size are known as static data structures. The memory for these data structures is allocated at the compiler time, and their size cannot be changed by the user after being compiled. However, the data stored in them can be altered. The array is the best example of the static data structure, as they have a fixed size and its data can be modified later. Second type is dynamic data structures. The data structures having a dynamic size are known as dynamic data structures. The memory of these data structures is allocated at the runtime, and their size varies during the runtime of the code. Moreover, the user can change the size as well as the data elements stored in these data structures at the runtime of the code. Linked lists, stacks, queues are common examples of dynamic data structures. Now, what are non-linear data structures? A form of data structure where the data elements don't stay arranged linearly or sequentially. Trees and graphs are the types of non-linear data structures. The nodes in the tree data structure are arranged in hierarchical order. In a graph, is with a finite number of vertices and edges, and these edges are used to connect the vertices. Data structures operations, the major or the common operations that can be performed on the data structures are searching. What is searching? We can search for any element in a data structure. Second is sorting. We can sort the elements of a data structure either in an ascending or descending order. Next is insertion. We can also insert the new element in a data structure. Then updation. We can also update the element, that is, we can replace the element with another element. And lastly, it's the deletion. We can also perform the delete operation to remove the element from the data structure. What are the advantages of data structures? The first advantage is the efficiency. If the choice of a data structure for implementing a particular ADT is proper, it makes the program very efficient in terms of time and space. Second, reusability. The data structure provides reusability, means that multiple client programs can use data structure. Next, abstraction. The data structure specified by an ADT also provides the level of abstraction. The client cannot see the internal working of a data structure, so it does not have to worry about the implementation part. The client can only see the interface. What is data structure algorithm? An algorithm is a process or a set of rules required to perform calculations or some other problem-solving operations, especially by a computer. The formal definition of an algorithm is that it contains the finite set of instructions which are being carried in a specific order to perform the specific task. It is not the complete program or code. It is just a solution, we can say logic of a program, which can be represented either as an informal description using a flowchart or a pseudocode. That depends upon the programmer how it develops the algorithm. We need algorithms because of the following reasons. Very first, scalability. It helps us to understand the scalability. When we have a big real world problem, we need to scale it down into small steps to easily analyze the problem. Now, what is performance? The real world is not easily broken down into smaller steps. If the problem can be easily broken into smaller steps, means that the problem is feasible. Example, write an algorithm to add 2 numbers entered by the user. So, the following are the steps required to add 2 numbers entered by the user. Step 1 will be start. Step 2, declare 3 variables, A, B and sum. Step 3, enter the values of A and B. Step 4, add the values of A and B and store the result in the sum variable. That is, sum is equal to A plus B. What will be the next step? Step 5 will be print sum and step 6 will be stop. What will be the result? We'll just get a sum. If it is 2 plus 2, we'll get a sum of 4. So, this is the procedure of any algorithm, starts and stops. What are the characteristics of an algorithm? The following are the characteristics of an algorithm, like first, input. An algorithm has some input values. We can pass 0 or some input value to an algorithm. Next is the output. We will get one or more output at the end of an algorithm. Unambiguity. An algorithm should be unambiguous, which means that the instructions in an algorithm should be clear and simple. Next is finiteness. An algorithm should have finiteness. Here, finiteness means that the algorithm should contain a limited number of instructions. That is, the instructions should be countable. Next, effectiveness. An algorithm should be effective as each instruction in an algorithm affects the overall process. Language independent. An algorithm must be language independent so that the instructions in an algorithm can be implemented in any of the language with the same output. What is data flow of an algorithm? Right? Whenever we make an algorithm, data flow is very important. What is the problem? A problem can be a real world problem or any instance from the real world problem for which we need to create a program or the set of instructions. The set of instructions is known as an algorithm. An algorithm will be designed for a problem which is a step-by-step procedure. Input. After designing an algorithm, the required and the desired input are provided to the algorithm. Processing unit. The input will be given to the processing unit and the processing unit will produce the desired output. What is output? The output is the outcome of the, or we can say the result of the program. What are the factors of an algorithm? The following are the basic factors we need to consider for designing an algorithm. Very first is modularity. If any problem is given and we can break that problem into small modules or small steps, which is a basic definition of an algorithm, it means that this feature has been perfectly designed for the algorithm. Correctness. The correctness of an algorithm is defined as when the given inputs produce the desired output, which means that the algorithm has been designed and perfectly designed algorithm, we can say that. The analysis of an algorithm has been done correctly. Next is maintainability. Here, maintainability means that the algorithm should be designed in a very simple, structured way so that when we redefine the algorithm, no major change will be done in the algorithm. Next is the functionality. It considers various logical steps to solve the real-world problem. Robustness. Robustness means that how an algorithm can clearly define our problem. It should be user-friendly. If the algorithm is not user-friendly, then the designer will not be able to explain it to the programmer. Simplicity. If the algorithm is simple, then it is easy to understand. Extensibility. If any other algorithm designer or programmer wants to use your algorithm, then it should be extensible. What are the importance of algorithms? When we talk about the theoretical importance, when any real-world problem is given to us and we break the problem into small modules, to break down the problem, we should know all the theoretical aspects. Secondly, practical importance. As we know that theory cannot be completed without the practical implementation. So, the importance of algorithm can be considered as both theoretical and practical. What are the issues of algorithm which we face? The following are some of the issues which we are going to discuss, which comes while designing an algorithm. How to design algorithm? As we know that an algorithm is a step-by-step procedure. So we must follow some steps to design an algorithm. How to analyze algorithm efficiency? Approaches of algorithm. The following are the few approaches we are going to discuss here, and we'll be using it and we'll be considering it both theoretical and practical importance of designing an algorithm. So first is the brute force algorithm. The general logic structure is applied to design an algorithm. It is also known as exhaustive search algorithm that searches all the possibilities to provide the required solution. Such algorithms are of two types. Optimizing is the first one, which means finding all the solutions of a problem and then take out the best solution, or if the value of the best solution is known, then it will terminate if the best solution is known. Next is the sacrificing. As soon as the best solution is found, then it will stop. Divide and conquer. It allows you to design an algorithm in a step-by-step variation. It breaks down the algorithm to solve the problem in different methods. It allows you to break down the problem into different methods, and valid output is produced for the valid input. This valid output is passed to some other functions. Next type is the greedy algorithm. It is an algorithm paradigm that makes an optimal choice on each iteration with the hope of getting the best solution. It is easy to implement and has a faster execution time. But there are very rare cases in which it provides the optimal solution. Next is the dynamic programming. It makes the algorithm more efficient by storing the intermediate results. It follows 5 different steps to find optimal solution for a problem. Very first, it breaks down the problem into a sub-problem to find the optimal solution. Second, after breaking down the problem, it finds the optimal solution out of these sub-problems. Third, stores the result of the sub-problems known as memorization. Next, reuse the result so that it cannot be recomputed for the same sub-problems. Finally, it computes the result of the complex problem. Branch and bound algorithm. The branch and bound algorithm can be applied to only integer programming problems. This approach divides all the sets of feasible solutions into smaller subsets. These subsets are further evaluated to find the best solution. Randomized algorithm. As we have seen in a regular algorithm, we have predefined input and required output. Those algorithms that have some defined set of inputs and required outputs, they follow some described steps, are known as deterministic algorithms. What happens that when the random variable is introduced in the randomized algorithm? In a randomized algorithm, some random bits are introduced by the algorithm and added in the input to produce the output, which is random in nature. Randomized algorithms are simpler and efficient than the deterministic algorithm. Backtracking. Backtracking is an algorithmic technique that solves the problem recursively and removes the solution if it does not satisfy the constraint of a problem. The major categories of algorithms are given below. Sort. Algorithm developed for sorting the items in a certain order. Search. Algorithm developed for searching the items inside a data structure. Delete. Algorithm developed for deleting the existing element from the data structure. Insert. Algorithm developed for inserting an item inside a data structure. Update. Algorithm developed for updating the existing element inside a data structure. What are the algorithm complexity? The performance of the algorithm can be measured in 2 factors. Time complexity first. The time complexity of an algorithm is the amount of time required to complete the execution. The time complexity of an algorithm is denoted by notation big O. Here, big O notation is an asymptotic notation to represent the time complexity. The time complexity is mainly calculated by counting the numbers of steps to finish the execution. Let's understand the time complexity through an example. Next is your space complexity. An algorithm's space complexity is the amount of space required to solve a problem and produce an output. Similar to the time complexity, space complexity is also expressed in big O notation. For an algorithm, the space is required for the following purposes: to store program instructions, to store constant values, to store variable values, to track the function calls, jumping statements, etc. What are the types of algorithm? There are basic two types of algorithm categorized in a two-way. First is the search algorithm and sort algorithm. Search algorithm, on each day we search for something in our today life. Similarly, with the case of computer, huge data is stored in a computer that whenever the user asks for any data, then the computer searches for that data in the memory and provides the data to the user. Second category is the sorting algorithm, which are used to rearrange the elements in an array or a given data structure, either in an ascending or descending order. The comparison operator decides the new order of the elements. Data structure is basically divided into two types of algorithm. So as far we have studied today about what are the data types and what are the structures of data, which is divided into two formats: primitive, non-primitive, linear, non-linear, static, dynamic. So all type of algorithms is basically divided into two parts, that is sorting algorithm and searching algorithm. Sorting algorithm are used to rearrange the elements in an array or a given data structure either in an ascending or descending order. When we talk about searching algorithm, like we search for anything in our day-to-day life, we search a data in a computer system by giving a typical type of or a defined type of algorithm in a computer system for searching. So today we have studied basically about what is data structure, what are the types of data structure, what are the factors of data structures, what an algorithm should have, what it should not have, how can an algorithm be made in a best way, how can we design an algorithm, what is flow chart, what are the steps of an algorithm. So that's all for today. See you on the next class. Thank you.